For today's session, I want to go on a slightly different tack. In my own research, we don't just use algorithms, we also obviously need to have data to analyze. And so today I want to think a little bit more about data and how you set it up in structures that makes it easy to analyze. The broad term for this is often putting data into a database, and I'd like to discuss some of the terminology and principles behind constructing databases, and also as a task today, have you build your own databases or think hard about what you need to do to construct a database. So let's begin with a simple example. Let's say we have three people, Amy, Ben, and Cam. Each of these people have certain properties, preferences, and skills. So, for example, Cam is 24 years old, his favorite color is orange, and he's fluent in English. He speaks a single language. I'm sure you're all familiar with tables, and one way to organize this information might be in a table. So displayed at the bottom of the slide, we have all of the information for Amy, Ben, and Cam, split out by age, how old they are, their favorite color, and the languages they speak. Remember, though, that a computer can't just simply store a table. This is a visual way of thinking about things. This is how we, as humans, perceive the world. If this was being coded up in a computer, it would need to just consist of very simple lines of code. And most importantly, it should be possible to hold an entire database in a single line of code. And that's what I'm going to try and get you to do later in this session. So let's look at this table again and think a little bit about the characteristics of what we have when we build a table, when we build a database. What's important in the table? Well, the principal rows and columns are in a different color gray, which tells you something straight away. It tells you there's something important about that information. In database speak, we would say that these headers represent a key to which all the other information is tied. So consider, for instance, the key Amy. The key Amy is tied to the information 37 green and then Swahili, French, English. Note that the key is special. Consider, for instance, the language English. The language English is not a key in the database. If it was, then we could uniquely associate other items with it. But English is, reading backwards, associated with green. It's also associated with blue. It's also associated with orange. It's associated with all of Amy, Ben, and Cam, the people. So one of the important aspects of a database is that we're tying the reference information to something, and that something is called a key. Here it's useful to stare at Amy, Ben, and Cam and think about how those people own the information. They are the keys in this database. The white information, or the information in the white fields in the table, are values associated with the keys. So, for instance, the key Amy and the key languages have values Swahili, French, and English. The keys color and Amy have associated value green. The important thing about the key is it's a unique piece of anything really, a unique word, a unique name, a unique something to which you can tie the information. And importantly, it has to be unique. And in this table, Amy, for instance, is unique, whereas English is not. Let's also think about some of the other properties of this table, the other properties of a database, a repository of information we have to build. One thing is that this table is self-contained. There's no additional, we could add information, we could add languages, we could add a name, we could add ages, but this is its own table. It isn't associated with, say, some table off in the distance of recipes with what ingredients are associated with each individual recipe. So you need some sort of way, some symbols, some syntax of blocking this off as its own database. As we've discussed, all of the information, the values in the table, are linked to specific keys, like Amy and age being the keys. And so we would need some syntax that if a computer was trying to read this information, it would say, okay, this is the key, this is the unique thing, the important thing, and here are the values that are linked to it. It's also important to note that some of the values have multiple entries. So under languages for Ben, it's not just one language, it's two, Spanish and English. So however we set up the way that a database is going to record information, we're going to have to be able to link one key to multiple different values. And so those are some properties of constructing a useful database. And as we've mentioned before, the keys, of course, are unique. Note that I'm giving you sort of a glib example here using names and values associated with people, but this is a very general, broad problem. In my own field of research, astronomy, names could be names of stars, for example. They could be things like Sirius or Procyon. And color could be the color of the star. And instead of it could be the age of a star, it could be the size of a star. So this is a very general way of storing information. And this is why databases are such a broadly used concept in computer science. So here are some properties, we'll get back to these, to dwell on when you're constructing a good database. 1, 2, and 3 are going to need to be the case. So here's what I want you to do in today's session. Have fun with it. I'm not going to show you any, well, I'll show you a little code, but not much code related to this. So you should be able to just do this, discussing it with other people or on a piece of paper or on a board on the wall. What I want you to do is let's reduce the table down to just the names and the languages. So Amy, Ben, and Cam are your keys. Swahili, French, English are the values for Amy. Spanish, English are the values for Ben, and English is the value for Cam, for the key Cam. I want you to come up with a way of writing this table on a single line. So I'm thinking about this like a single line of code. So if you're working on a piece of paper, it's got to fit on one line of a piece of paper. If you're working on a whiteboard on a wall, you've literally got one line that you're going to have to write down all of this information. You can't display it like a table like this. And it's going to have to include these properties. It's going to have to be clear that the table, the database, is self-contained. It's going to have to be clear that some values are keys and some are values. Some words you're writing down are keys and some words are values. It's going to have to be clear how the values link to the keys. And you're going to have to allow separate values potentially to store Swahili, French, and English. So each key is going to have to be associated potentially with multiple values. So think about those properties, or go back to the slide I just showed and look again. And your task is to try to write down this entire table at the bottom of the slide using just the 6 symbols that I've shown you in the bullet point. So pairs of curly braces, pairs of square brackets, a colon, and a comma. That's all the syntax you're allowed to use to try and construct this table with all of the information, the properties I asked for from this slide. If you find that easy and you get through rather quickly, the first thing to do is to share your one-line description of this entire table, or rather this entire table, with a colleague and have them agree that it adequately represents the information in the table. Or have them point and say, wait a minute, this isn't right because keys need to be associated with multiple values and you haven't done that. Or you need to have a single, somehow illustrate it's a single self-contained table or database and you haven't done that. So have a colleague critique your work. If you still find that you got through this rather quickly, try additionally to construct a database for the full table at the bottom of this slide with age and color included. For this version, you're going to need keys within keys. So the key Amy is going to have, the database key Amy is going to have 3 keys associated with it: age, color, and languages, and each of those keys is going to have a value or values associated with it. And again, please only use the 6 symbols, the curly brackets, the square brackets, the colon, and the comma in constructing a one-line representation of this entire table.